Hi guys, welcome to a new video on differentiation, paper 2 questions under math studies. This video deals with questions of a level 4 upper intermediate level of difficulty, and they tackle questions where the F double dash test is required. I shall solve the two questions on the screen in front of you, and I shall begin with the first question shortly. I shall now attempt to solve paper 2 November 2010 question 5. Kindly take a minute and attempt to solve, and the answer shall follow through shortly. So in question A, you are required to write down f of 0 given this function f of x. So I simply substitute the x with 0, and any term that has x shall be cancelled out. So this is 0, 0, 0, and hence f of 0 equals to 30. Next, I need to find f dash of x. So there is your original function in black, and there is your derivative function in red. Next, I'm required to find the gradient of the graph of f of x at the point where x equals 1. So the gradient of the graph is given by f dash of x. So I simply substitute x equals 1 into f dash of x. This is what I've done. 3x squared minus 6x minus 24 becomes 1 squared minus 6 times 1 minus 24. This gives me negative 27. Next, I'm told that the graph of f of x has a local maximum point m and a local minimum point n. I'm required in I to use f dash of x to find the x coordinate of m and of n. Bear in mind that they said use f dash of x, so you cannot simply get the values from the calculator. You have to show your work out, and you should know that minimum and maximum points have x coordinates that correspond to f dash equals 0. So in order to find these x coordinates, I shall set f dash of x to 0. So since f dash of x equals 0, then 3x squared minus 6x minus 24 equals 0. You can divide by 3 all of the terms on the left and on the right, getting x squared minus 2x minus 8 equals 0. Then you can factorize, getting these two values of x. And now that I've shown an understanding of how to get the x values of the turning points, I can use the GDC to get the actual coordinate points. So I've written the equation down, and there is my window for your reference, and there is what the graph should look like. I shall find the maximum using this function, second trace maximum. There is my maximum point, so a left bound should be somewhere here, a right bound there, and there is the maximum point. So the calculator tells me that the maximum is at negative 1.999, or just negative 2 and 58. There is my maximum point. Next, for the minimum, I shall choose the minimum function. There is my left bound, right bound, and guess. So the calculator tells me that the minimum exists at 4 and negative 50. So these are the coordinate pairs of the 2 points, the maximum and the minimum. Next, I'm required to sketch the graph of f of x for -5 less than x less than 7 and -60 less than y less than 60. So let's just adjust our window to reflect the new question, the new requirements. So the window should look like this, and there is your function, and you should sketch. So you get 1 mark for the correct window, a mark for a smooth curve with the correct shape similar to your GDC, and the axes intercepts should be approximately in the correct position, so there and there, as well as there and there. So you can get these from the calculator. This is approximately after -4, slightly after -4. This is approximately at 1, and this is approximately at 6. So these are the marks, and finally a mark for m and n, marked correctly on your diagram, the local maximum and the local minimum. Make sure to indicate the window on your sketch that you understand that the graph goes from -5 up to 7 and from -60 to 60, because if you don't do that, you shall lose at least 2 marks out of the 4. So moving on. Lines L1 and L2 are parallel, and they are tangents to the graph of f of x at points A and B respectively. L1 has equation y equals 21x plus 111. I'm required to find the x coordinates of A and B and the y coordinate of B. So the first keyword in this question is parallel. The lines are parallel, so I should infer that they have the same slopes. So I should look for the slope of either line, and I realize that I'm given the slope right there of L1. The slope is 21 because this is an equation in the form y equals mx plus c. So this is your m, 21. Hence the slope of L1 and L2 is 21, and in order to find their x coordinates, I shall simply equate f dash of x to 21. So I've equated f dash of x to 21 because this is the value of the slope, and I need to find the x coordinates. There is some simple algebra to be done. Here I divided everything by 3 to get this equation, and then I factorized, and your answer is 5 and -3. So since A comes before B, hence the x coordinate of A is -3 and the x coordinate of B is 5. Finally, I want to get the y coordinate of B. This is simply done by plugging the 5 into the original function and getting the value of y. So let's take a look. So second trace value, and I enter 5, and the calculator tells me that the y value is -40. So this is my answer. So take a minute to check the answer out if you will. I hope you have found this useful. I shall now attempt to solve November 2013 question 4. Kindly take a minute, attempt to solve, and the answer shall follow through shortly. So for the given function, I'm required in A to find f of -2. So using your GDC, just write the function down. There is my function, and I click on trace, and second trace value, and you plug in -2, and the calculator tells you that y equals 4. The manual way to do this is to plug -2 into each x in this equation, and again using your calculator find the answer. So in B, I'm required to find f dash of x. So there is your derivative function. In question C, I am told that there is a local minimum when x is -2. I want to show that there is another local minimum at x equals 3. So we should know that a local minimum exists when f dash equals 0. However, this applies to both the minimum and the maximum. So we need to prove that f of dash of x is 0, and to prove something else that tells me that this point is a minimum and not a maximum. And if you check our earlier videos, you'll see a technique where we obtain the second derivative of f. We obtain f double dash of x, and if f double dash is positive, then the point is a minimum. If f double dash is negative, then the point is a maximum. So you have to prove that this is a minimum and not a maximum. So first we get f dash of x equals 0. We have to do this manually because this is a show that question. You cannot just use your GDC. There is your equation, there is f dash. I've taken out a common factor. Then I factorized the bracket, this bracket right there. And this tells me that there are 3 turning points when x is 0, when x is 3, and when x is -2. I now need to test whether x equals 3 is a minimum or a maximum, or to demonstrate that it's a minimum and not a maximum. So we shall conduct the double dash test. In order to do that, I shall differentiate this red function right there, obtaining f double dash of x, which is 9x squared minus 6x minus 18. Then I shall plug the x coordinate of the turning point that I want to test into f double dash. Since the answer I got was positive, hence the curve has a positive concavity. It looks like it's smiling, as you can see. Hence this point is a minimum. You don't really need to talk about concavity, you just mention that since f double dash is positive, hence the point is a minimum. Next, you are required to sketch the graph of the function for -5 to 5 in the domain and -40 to 50 in the range. So we shall use the GDC to do that. There is my equation. There is my window according to their instructions, and there is what the function should look like, and I should copy this down into my sketch. You are also asked to indicate on your sketch the coordinates of the y-intercept. You should know that the y-intercept exists when x is 0. Hence, going back to the original function, I shall plug 0 instead of x. So this term is cancelled, and this term as well. All the x's go to 0. Hence, your y is the only non-x term, or the only constant, which is 20. So the y-intercept is 20. So you get a mark for labeled axes and an indication of scale. a mark for a smooth curve with the correct shape, a mark for local minima in second and fourth quadrants. So the minimum should be here in negative x, positive y, and the other minimum should be in negative x, in positive x, negative y, excuse me. So this is the second quadrant, this upper left quarter, and this is the fourth quadrant, the bottom right quarter. So you should make sure your drawing is accurate in this sense, and it matches what we have in the GDC. Next, you want to make sure that your y-intercept is seen and labeled 0, 20 or just 20 on the y-axis as they've done right there. You lose one mark if this turning point was drawn on the x-axis. As you can see, it is slightly above, and again this is apparent on the GDC. It does not touch the x-axis, so watch out. Next, in E, you are required to write down the coordinates of the local maximum. So second, trace maximum, left bound, right bound, guess. So the maximum exists at this weird number, which we have said before just means 0, because e to the power of negative 6 is just 10 to the power of negative 6. So this e negative 6 on the calculator means 10 to the power of negative 6. So this is 0.000001475. So this is negligible. This just means 0. It's a machine error. It has to do with the calculator itself. So the maximum point exists on 0, 20. Let t be the tangent to the graph of the function at the point 2, negative 12. Find the gradient of t. So I just want the gradient when x equals 2, and I use the GDC. So second, trace dy by dx, and you just press on 2, and the calculator tells you that the gradient when x is 2 is negative 24. So there are your answers to E and F, and they were obtained using the GDC. The line L passes through the same point 2, negative 12 and is perpendicular to T, and it has an equation in this form. Find the gradient of L. So the gradient of L is obtained from the gradient of T. The gradient of T is negative 24, hence the gradient of L is positive 1 over 24. This has to do with the gradients of perpendicular lines. You switch the sign and you flip. So negative becomes positive, 24 becomes 1 over 24. Next you want the equation, and you have the gradient and the point, so this is easy. So there is your point and your slope. You just plug into the point slope formula. Since I want the numbers to be integers, I want to get rid of this denominator, so I will multiply by 24. This is just algebra. I get this equation and I expand to get this equation, and then some simplification. Hence your B and your C are provided as follows. Take a minute to look at the answer again. We are done. I hope you have found this useful.